Continuing with the periodic trends, we will learn about electron affinity now. Electron affinity, the energy released when an atom in the gas phase accepts an electron. It is the opposite of ionization energy. So that means Cl gas, when it accepts an electron, it forms Cl minus, and the energy released during this process is the electron affinity. Larger the positive absolute value, more favorable the addition of electron is. Addition of second electron is very difficult, and hence second electron affinity is mostly unfavorable. One thing which you have to note down here is, in the book sometimes the electron affinity is given as a negative value, sometimes it's given as a positive value. But when you are comparing electron affinities, take the absolute values and take the absolute positive values to compare electron affinities of different elements. Now let's look at the trend in electron affinity. Electron affinity decreases in a group because size increases, so it will be difficult to add an electron. However, electron affinity increases in a period because the effective nuclear charge increases and the hold on the added electron is more. And the energy of group, some of the things which you should remember is, energy of group 2A is lower than 1A due to completely filled s orbital. Like 2A doesn't really accept an electron. And electron affinity of group 5A, which has the P3, is lower than 4A, which is P2, as it is easier to add an electron to an empty orbital. And the order of electron affinity in a period, in general it should increase in a period, but looking at the graph you can see that the pattern is not steady increase. You can see that when you go from lithium to neon, so many anomalies are there. For example, from lithium to beryllium, beryllium has lower electron affinity, and carbon has got a higher electron affinity. Between nitrogen, oxygen, fluorine, the trend is pretty okay. So it's not as simple as ionization energy. There are a lot of anomalies, so you have to remember these things in order to predict which one has a higher electron affinity. Identify the elements with higher electron affinity. Fluorine and bromine, they belong to the same group, and hence fluorine will have a higher electron affinity as electron affinity decreases in a group. Now the next is sodium and sulfur. They belong to the same period, and hence sulfur will have a higher electron affinity as electron affinity increases in a period. And the next thing will be, you will need to refer to the graph to answer the electron affinity between phosphorus and silicon. Phosphorus and silicon, silicon will have a higher electron affinity because electron affinity of group 4A is greater than electron affinity of 5A. Potassium and calcium, they belong to the same period. However, calcium has completely filled orbitals. Therefore, potassium has a higher electron affinity. Cl minus and O minus. Cl minus, the orbit gets filled up. Therefore, I cannot add one more electron, and hence O minus has got a higher electron affinity. Bromine and arsenic, Br and arsenic, Br will have a higher electron affinity because bromine and arsenic belong to the same period, and electron affinity increases in a period. Or in general I can say that elements on the left side of the periodic table, group 1, 2, 3, etc., they prefer to lose their electron and will have a higher ionization energy. And elements which belong to the group on the right hand side of the periodic table, group 6, 7, leave out the inert gases, they prefer to add an electron to attain the inert gas configuration, and hence they have higher electron affinity as they form preferably negative ions.